Welcome back. So far we have covered how networks are built and how routers forward data. Today we're talking about VLANs, virtual local area networks. We're going to talk about what they are, how to set them up, and the two ways to route traffic between them, plus a live Cisco packet tracer demo. Let's jump in. A VLAN, virtual LAN, is a way to logically separate a physical switch into multiple virtual switches. Without VLAN, all ports on a switch are in one big broadcast domain. Everyone hears everyone else's traffic. With VLANs, you group ports into isolated virtual networks. Ports 1 through 5 can be VLAN 10 for HR. Ports 6 through 10 can be VLAN 20 for sales. Devices in VLAN 10 can talk to devices in VLAN 20 even though they are plugged into the same physical switch. It's like having separate switches without buying more hardware. Why use VLAN? Better security, departments are isolated, better performance, broadcast stays within the VLAN, and flexibility. You can move device to a different VLAN without touching cables. Just change the port configuration. Basic VLAN setup. Here's the real VLAN setup. At the top, you have the internet connection coming into the router through the WAN interface. Below that, a layer 3 switch connects to a multiple layer 2 switches. Each layer 2 switch has port assigned to different VLANs. Look at the first switch, VLAN 5 and VLAN 6. Another switch has VLAN 2, another has VLAN 3 and VLAN 4. Devices in VLAN 5 can only talk to the other devices in VLAN 5 unless we route them together. The switches connect back to the layer 3 switch via trunk links. The layer 3 switch handles routing between VLAN internally. This is a real bold setup. Access layer switch connecting end users and distribution layer switch handling the routing. Inter-VLAN routing. Two ways to route VLAN. There are two ways to route traffic VLAN. One is switch virtual interface or SVI. You use layer 3 switch, a switch that can also route the switch itself, perform the routing, no internal router needed. And the other option is router on a stick. You use standard layer 2 switch and connect a router on a single trunk link. The router does all the routing between VLANs. SVI on layer 3 switch, no internal router needed. The switch itself does routing. Oh, look at the PC. All three are on VLAN 100 with IPs 10.10.10.2, 10.10.10.3, and the SVI on the switch at 10.10.10.1. The SVI is a virtual interface inside the switch. You can configure it like this. Interface VLAN 100, IP 100, interface VLAN 100, IP address 10.10.10.1/24. That becomes the default gateway for every devices in VLAN 100. Since they are all the same VLAN, they can communicate directly through the switch without routing. But if you have multiple VLAN, say VLAN 100 and VLAN 200, each with their own SVI, the layer 3 switch will route between them at wire speed. No trunk bottleneck, no external router, clean and fast. Now we talk about router on the stick. Router on the stick. Here's the router connects on the internet with the IP 192.168.0.1 with the Giga port 1 on the switch connects to the router with IP 192.168.0.2. That's the trunk like carrying all VLANs. The router splits that single physical connection in sub-interference where the G2 handles VLAN 10 with IP address 192.168.1.1 with G10 handles VLAN 20 with IP 192.168.3.1 where the G20 handles VLAN 30 with IP 192.168.3.1. On the switch side, those same interface numbers connect to devices in each VLAN. The switch tags traffic from G2 as VLAN 10, G10 as VLAN 20, and G20 as VLAN 30. All three travel up to G1 trunk to the router. When a device in a VLAN 10 wants to reach VLAN 20, traffic hits to the switch on G2, gets tagged, goes up to the trunk. Reaches on the router G2 sub-interface, gets routed, exits to the G10 sub-interface, and travels back down to the same trunk to the switch. One cable, one physical port, multiple VLANs. That is the router on the stick. Now we're gonna go a Cisco packet tracer live demo, and we're gonna do router on a stick and SVI switch virtual interface. Okay, now we're gonna do SVI switch virtual interface. Now I'm gonna get one of these layer 3 switches and 3 PC. Now that I got 3 PC, now we're gonna connect them. Now that I'm done connecting them, I'm gonna configure everything and label everything. Now that I finished labeling, we can see that VLAN 10 is going to be sales with a network of 192.168.10.0 with the /24 network subnet mask with a default gateway of 192.168.10.1. And PC0 is going to be VLAN 30 name admin with the 192.168.30.0 with /24 subnet mask, and that's the network, and the default gateway of 192.168.30.1. And for PC1 is going to be VLAN 20 name guest with a network of 192.168.20.0 with a subnet mask of /24 and the default gateway of 192.168.20.1. Now we're going to the multi-layer switch, layer 3 switch, and go CLI, enter, and press no, enter. Now we type enable, enter enable, and now we type configure terminal. First, we're gonna name our switch, host name. We're gonna name it switch 1, W1, press enter. And most of the modern switch can support thousands of VLANs. Now we're gonna create our VLAN via typing VLAN 10. Now that we created our VLAN 10, we're gonna name our VLAN, and that VLAN name is going to be sales. Press enter, exit. Now that we created VLAN 10, we're gonna create VLAN 20 and VLAN 30 with their name labeled. So VLAN 20 and VLAN 20 name is guest, exit, and we're creating VLAN 30, enter, and the name of our VLAN 30 is going to be admin. Press enter, exit, exit again, and to show if we created our VLAN, you type show VLAN. As you can see, we created VLAN 10 as sales, VLAN 20 as guest, and VLAN 30 as admin as active status. Now that we're done creating VLAN, now we add port to our VLAN. To add port in our VLAN, you go to configure terminal, enter, and we type interface fast internet 0/1. That's because fast internet 0/1 is connected to VLAN 10. Press enter, and you type switch port mode access, and then switch port access VLAN 10. Now that we added VLAN 10 to our interface fast internet 01 port, we're gonna do the same to the VLAN 20 and VLAN 30. Exit, internet interface fast internet 0/2, switch port mode access, and switch port access VLAN 20. Exit, and interface fast internet 03, and switch port mode access, and switch port access VLAN 30. Press exit. Now that we're done adding port to our VLAN, now I'm going to configure the access point for the end devices. And our end devices is going to be PC2, PC1, and PC0. And we start at PC2. We go to desktop and IP configure. Because our default gateway is going to be 192.168.10.1, I'm gonna give this PC an IP address of 192.168.10.2 with subnet mask of /24. And the default gateway is going to be 192.168.10.1. And we're gonna do the same to PC0 and PC1. For PC1 and VLAN 20, I gave him 192.168.20.2 with subnet mask of 255.255.255.0 with a default gateway of 192.168.20.1. Now we're going to PC0, desktop IP configuration. I'm gonna give him IP address 192.168.30.2 with a subnet mask of 255.255.255.0. And the default gateway is going to be 192.168.30.1. Now that I'm done giving an IP address, subnet mask, and a default gateway, now the last thing to do is to configure each VLAN with the IP address. Now we go back to the switch and we go to the configuration terminal and you type interface VLAN 10, press enter, and the line protocol on interface VLAN 10 is going to change to say to up, and you type IP address same as before with 192.168.10.1 as our default gateway with 255.255.255.0. Press enter. Now the interface for VLAN 10 is added with the IP address. Now we're gonna do the same for VLAN 20 and VLAN 30, and we're gonna do the same configuration. Interface VLAN 20, IP address 192.168.20.1, subnet mask of 255.255.255.0. Exit. Now we're gonna do interface VLAN 30, enter, with the IP address of 192.168.30.1, 255.255.255.0, enter, exit. And the last thing is you type IP routing. You use IP routing on layer 3 switch to activate its routing engine so it can forward traffic between VLAN using routing table instead of just switching at layer 2. Press enter. Now that we configure everything, we're going to try to ping PC2 to PC1. So we're pinging PC1 using PC2. We go command prompt, ping 192.168.20.2 because that's the IP address of PC1. IP address of PC1 is 192.168.20.2. Press enter. The first ping is going to fail because ARP. Now we press enter. And now our ping is getting a reply back from 192.168.20.2. That means our configuration is working. Now we try to ping VLAN 30 admin with the IP address of 192.168.30.2. The first ping failed because of ARP, and the other ping did come out with a reply from 192.168.30.2. And that is SVI. Now that we've done SVI switch virtual interface, we're gonna do the router on a stick. First, we're adding router, and then we're adding a switch layer 2, and 4 end devices, PC. And now we're gonna connect everything. Now that I'm done connecting everything, I'm gonna label everything so it's easy to understand which is which in our port. Now that we label everything to help you virtualize, now we get started. First thing to do is to run no shutdown on the router to get this red arrows turning green. Press enter, and you type enable, press enter. Configure terminal, press enter. And then we go to the interface gigabit internet 0/0/0, press enter. And now we run no shutdown. As you can see, line protocol interface gigabit internet 0/0/0 changed to static to up. Now you can see the line is turning green. Press enter. Now we're going to the switch and create the VLANs. So click the switch and go to the CLI. Press enter. Now we do enable. Enter. Configure terminal. Enter. Now we're creating VLAN, and VLAN can be any number between 1 and goes to 1,000. But for the purpose of this video, I'm just going to choose VLAN 10 and VLAN 20. Press enter. And now I'm gonna name my VLAN 10 as admin as we label right here, and VLAN 10 admin name, and with the network of 192.168.10.0 with the subnet mask of /24 and the default gateway of 192.168.10.1. And for our VLAN 20 name guest, 192.168.20.0 with /24 subnet mask with the default gateway of 192.168.20.1. Now we go back to switch and we name it admin. Press enter. And then we type exit, and we going to repeat this process for VLAN 20. Enter. And the name for our VLAN 20 is going to be guest. Enter. And press exit. Now what I'm going to do is stay on this config, and I'm going to go into this interface to 2345 and configure the VLANs. So I start typing interface fast internet 0/2. Enter. And type the command switchport mode access, and type the command switchport access VLAN 10. That's because fast internet 02 and fast internet 03 is in VLAN 10, and fast internet 04 and fast 05 is going to be VLAN 20. Type exit. Now that we are done at fast internet 02, we're gonna repeat these commands for the next interfaces to 3 to 5. So interface fast internet 03, switch mode access, and switchport access VLAN 10 because fast internet 03 is in VLAN 10. Press enter. Exit. Interface fast internet 04 and switchport mode access. Because interface fast internet 0/4 is in switchport access VLAN 20, so we add switchport access VLAN 20. Enter. Exit. And we're gonna do the same at the interface fast internet 0/5. Switchport mode access. Switchport access VLAN 20. Exit. Now that we have assigned ports to the VLANs, now I'm going back to the router. Now that I'm back to the router, I'm going to create the sub interface. So I type enter, configure terminal. Now I'm going to type interface gigabit internet 0/0/0.10 at the end to indicate that this is a sub interface for VLAN 10. Now we press enter. As you can see, the interface gigabit internet 0/0/10 changed to state of up. Now I'm going in the sub interface configuration. Here I'm going to type encapsulation.1q.10 and press enter. And I'm going to add IP address 192.168.10.1 with subnet mask of 255.255.255.0, and the IP address 192.168.10.1 is from the default gateway of VLAN 10 192.168.10.1, and the subnet mask is from VLAN 10 with the /24 255.255.255.0. To be specific, it's the default gateway for the VLAN sub interface we have been configuring. And then we enter, type exit. Now we're gonna do the same as the VLAN 20. In here, interface gigabit internet 0/0/.20 instead of 10 because we're configuring VLAN 20. Press enter. As you can see, it changed the state to up. Now we're adding encapsulation.1q.20 instead of 10. Press enter. And we're adding the IP address 192.168.20.1 with the subnet mask of 255.255.255.0. That's because the default gateway of VLAN 20 is 192.168.20.1 with the subnet mask of /24. And press enter. Now we're going back to the switch. Now we're going to configure our trunk port, and our trunk port is going to be the interface of if fast internet 0/1 that connects to the switch to the router. In a router on a stick, this is always the trunk port. This cable is always going to be the trunk port. Now we go back to the switch and we're in configure terminal, and we're gonna type interface fast internet 0/1 because we're making this a trunk port. Press enter. Now I'm going to type this command switchport mode trunk. As you can see, it changed to state to up. Press enter. And now I'm going to type in switchport trunk allowed VLAN 10 and 20. Press enter. Oh, it did not like that. So now we type switchport trunk allowed VLAN 10 and 20 and press enter. And that should be it for configuring the router and the switch for the router on a stick. If there's something I missed, we'll soon find out. Now that we have to configure the IP address and default gateways to our end devices, so I'm going to start at PC0 to add IP configuration for our main devices. Because VLAN 10 admin is in the network of 192.168.10.0, I'm giving this 192.168.10.2 with the subnet mask of /24, and the default gateway is 192.168.10.2. And for PC1, the stop configuration 192.168.10.3 with subnet mask of 255.255.255.0, and the default gateway is 192.168.10.1. And for the PC2 in the VLAN 20, go to desktop configuration. I'm giving it 192.168.20.2 because that one is already taken with the default gateway of 192.168.20.1. And the PC3 desktop configuration 192.168.20.3, subnet mask of /24, default gateway of 192.168.20.1. Now I'm going to use PC0 to ping PC3 with the IP address of 192.168.20.3. Ping 192.168.20.3. Press enter. I'm sorry, the first ping did not go through because I misconfigured the default gateway. I put 192.168.10.2 instead of 1, so that's why the first ping did not go through. Now that I fixed that problem, we're gonna try to ping PC3 with 192.168.20.3. So ping 192.168.20.2 and ping 192.168.20.3. Nice, everything is working. So VLANs logically separate your network for security and performance. Trunk ports carry multiple VLANs between switches using 802.1q tagging. To route between VLANs, you have two options. Router on a stick, simple, works with any layer 2 switches, but limited by trunk speed. SVI on layer 3 switch, faster, scalable, and what enterprise actually use. Build on both packet tracer. Once you configure VLANs trunking and routing by hand, you will own the concept. Thanks for watching. Make sure you add question in the comments and see you next time.